This is a Bluffers guide to entity relationship modelling and relational databases. It's a quick overview of modelling data and creating a relational database. The object is to get as much as possible in as short a time as possible. A lot of talk these days about other kinds of databases, object-oriented database, NoSQL databases, in particular handling big data using things like Hadoop, the generic principle of MapReduce. All very important, all very future-looking, but the vast majority of databases used today and will be used for some time to come are relational databases. The central principle of design of a relational database is to identify entities. Entities are things that we keep data about. They can be physical things like a car, room, book. Can be people. They can be abstract. You keep information about an event, a department, an issue. Also identify attributes. For example, the entity person is going to have a name, address, date of birth, and so forth. Often an attribute is just that. It's a number, a text, a boolean, in which case it's just an attribute. But it is possible for an attribute also to be... I paused because I didn't expect that bicycle to move. Anyway, you'll notice I've got pegs under BMX. If that attribute was yes or no, it would just be an attribute, full stop. It's an attribute of BMX. If it was an Olympic bike and pegs, you had to record what alloy it was made of and when it was made and how many times it's been used, then it would also be an entity because it would have its own attributes. As well as the entities and their attributes, we need to record the relationships between the entities. And there always are. For example, between patient and doctor, student and course, vehicles and owners, swimmers and racers, all examples where one entity is related to the other. And the common ways in which they're related are shown with the lines one to many or many to many. And it can be either or it can be both. For example, you might be related to your doctor on the grounds that a particular doctor is your doctor. So you, amongst with other people, are related to one doctor. The one doctor is related, of course, to many of his patients. But you might also have a relationship many to many if you're at a practice where you don't know who you're going to see and you need to record treatments. There you would have a relationship to many doctors. So it can vary and it can be both of them. And that's how we do the modelling. We say we're going to have a swimming gala, we've got swimmers and they're going to enter into races, and the swimmers comes from a club. And so we say, right, a swimmer will belong to one club will have many swimmers. Swimmer will go into many races, a race will have many swimmers in it. Right, I've got my model of the real world. And it crops up all the time. We can see below a similar example. Customer makes an order, the order is for one customer, but customer will probably make a lot of orders, and each order is likely to contain lots of different products. And of course a particular product might be featured in lots of orders. And something or way, say you wanted a database for a gig manager system. You'd put down all the entities you could think of. You'd have musicians, bands, gigs, venues, and so you look to how they're related. A musician obviously belongs to a band, and a band will have many musicians. Musician might actually play more than one band, so there you've got many to many. Same with gigs. Band will play lots of gigs, and a gig will usually have more than one band. Venue, well, gig will only be at one venue, so that's one to many. We've done an analysis of entities and relationships, and we can now get moving. This is fine as far as the real world is concerned, but you can't make a database using those entities and relationships. Won't work. It's a basic principle of the relational database that attributes must have what are called single values. Or to put it another way, if you think of the entity as a table, each cell must be atomic. So it's not allowable to have something like those tables I've got there. You see, if I wanted to implement this model of club, swimmer, race, I'd have to have in swimmer, for each swimmer, I'd have to have more than one race. Or do it the other way around, for each race, I'd have to have more than one swimmer. And that just isn't allowed. It won't work. A relational database must have a single value in each cell. Now, there are lots of ways of looking at that, and you can what we call normalize data by doing some theoretical exercises on it, ending up in the end with these sorts of tables. But the entity relationship model gets you the same answer, but much more quickly. I don't know why, but there's a second example. Again, in order to make it work, we've got multiple values in one of the cells, and that isn't allowable. In designing a relational database, we use the concept of the intersection entity. If you've got entities which are joined with many to many, doctor, patient, swimmer, race, and so forth, you introduce a new entity and you don't give it a name, you call it X. Important not to give it a name. If you give it a name too soon, here we gave it a name entry because we thought we don't need to put X. The thing between swimmer and race is entry. But as soon as you do that, you say to yourself, well, a swimmer might enter several races, so obviously the relationship between entry and race must be one to many. And you make a mistake, of course, because when you come to look at it, it's definitely wrong, isn't it? An entry is just for one race. And what cinches it is, of course, a race has got to have more than one entry in it. So we made a mistake, and we made a mistake because we wrote entry too soon. Always put X and draw the cardinalities. Cardinalities, the many to many, one to many, or whatever. And here's an example of it. In riding stables, we might keep a record of which jockey rides which horses, and that's many to many. We put X in, we take the crow's feet from the opposite end, drag it round and put it to the new entity. Do that from both sides, and we've now got the structure right. We can now afford to replace X with something like ride or outing or something. And if we do it that way, then we are entries atomic. We've now got tables which don't break the rules. Each table has got attributes which have got only one value in them. And we've still got the information, because if we want to know who's ridden red rum, we look at the outings table and find it's... Oh, I've made a mistake there. I've got H1J2 twice. Not sure how I did that. Forget one of those, but H1J2 and H1J1. So obviously they've both ridden red rum. Back to something you're more familiar with, the gig manager. The many-to-manys here, we get rid of them in the same way. Might be a bigger one, but it's no more complicated. You just take each one on its own. Between musician and band, you put X, transfer the crow's feet, and then you say, what could we call this X? Well, probably lineup is what musicians would use about the relationship between musicians and band. And then what between band and gig? Well, here it says performance. Later on I'm going to use the word spot because I got mixed up. Performance or spot. Anyway, it's an intersection entity that started off as X. And now we've done that, we take this picture and we say from that picture we will make some tables. And we have these tables. And never mind whether it's int or varchar or string or whatever, it all depends on the database. So the second column doesn't matter much. It's the first column that matters. What data do we keep about musician, about lineup? And the important thing to note is that where you've got an intersection entity, that's lineup and spot, you always have the IDs of the surrounding tables. So lineup must have a musician ID and it must have a band ID. Can have other things. For example, here we've got instrument because, of course, a musician might play bass in one band and rhythm in another. And spot. Because this is keeping information about the band's gigs, we've got to have the band ID and the gig ID in it. Now we've got the tables, we can use them, and a relational database is accessed whether directly or through a program using SQL. Incidentally, even if you use MS Access, where it's all graphic and filling in tables, it still uses SQL, just it has simpler interfaces that users use, but behind the scenes it's still generating structured query language. And the best way of getting used to that is having a quick play with an interface at hncd.co.uk ox SQL test PHP. If you go there and you enter show tables, you'll get a list of the tables in this database. There's quite a lot of other ones as well as the band gigs. Use this database for people to practice on doing lots of different things. So it changes from day to day, but all the band things are in there. And if you then type describe and then give the name of a table, it will give you a description of what that table is. So here, if you say describe band, it will give you what you've seen before, the field name and type. It'll also give you some extra information. Entering select wildcard, wildcard is an asterisk, select asterisk from band, it will print all the data in the band table. Change that and say select wildcard from band where genre equals indie, and it will print only those bands that describe themselves as indie bands. Incidentally, if that failed, or any of these fail, it could be that you've copied it from here and smart quotes are interfering. Whenever you get a problem, the first thing to do is look for those single quotes and just replace them in the interface. That usually makes things work. So there are some very simple ones. You get complicated ones, but they're not that complicated when you come to look at it. If I want to know the names of the people who are the musicians in Hunky Dory, then I've got to ask it to look at Hunky Dory, because that's the band I'm looking at musician, because it's the names of the musicians I want. But because those two are not linked directly, it's also got to look at lineup. So I tell it to select the name of the band and the last name of the musician, and then I say you've got to get that information from the band table, the lineup table and the musician table. And you've got to make sure that the ID of the band in the band table is the same as the ID of the band in the lineup table, and that the ID of the musician in the lineup table is the same as the musician ID in the musician table. And since we only want one band, we say, and the band name is Hunky Dory. And so we get that information. And very often we have fairly complicated SQL expressions because we have to look at lots of tables. You might be asked which bands have played at the Dog and Parrot. Well, here again, all we want is a band name, which is in the band table. But in order to get to the venue, we've got to go via spot and gig. So we've got to say, look at the band table, look at the spot table, look at the gig table, look at the venue table, get a chain from one to the other. That is ID equals ID all the way down until we say the venue name is Dog and Parrot. And that way, the database will print out those bands that have played at the Dog and Parrot. And finally, how do you get a program to do it? Well, it depends what you're programming in. Every programming language has got its own way of doing it. This is PHP because it's simplest of all. You connect to a database using some function that's already declared for you in the language you're using, and then you send an SQL string to the database and it will send you back a table, and that table here we call result, and then I use a bit of code to analyze that table to print it out. And finally, if you were using Access, this is the same thing, though it's got one or two extra things in. It's got coaches, which we didn't have before, and sponsors for the gala. And also, yeah, this was in fact used for an assignment at one stage, so I made it more complicated by members having to be qualified and so forth. But you can see it's got the same structure as the one we've been looking at. And that's, I hope, a very quick run through. I have to see now how long it took.